In this video, I am going to spend a lot of time talking about how you can use both the addition principle and the multiplicative principle together to solve what we often call two-step equations. Hopefully we can kind of move past that and get into more involved equations as well. Okay, so we're going to get started with really just naming some different components so you can have a strategy going forward of knowing where to start. So I think it's kind of important that we are able to identify different components of single variable equations. So I'm looking at this equation right here. 3p minus 7 is equal to 11. I'm hoping that students can get comfortable with the term coefficient and can recognize that 3 is a coefficient. And really what that means is 3 is the numeric factor of the term 3p. Okay? The negative 7 is a constant, and it has no term with it. So it's not a non-variable term. So we have the coefficient term, and then we have the constant term. And technically, 11 would be another constant on the other side of the equation. So we're going to find that you move forward and that the 3, being it's a coefficient, is very different than the negative 7, which is a constant, and we treat them very differently. It's going to make it very helpful for you to recognize how to start in solving a problem. So when we're looking at this expression here, equation, 7y plus 5 is equal to 2y plus 10, I want you to recognize that 7 is a coefficient and 2 is a coefficient. Those are both numeric factors of a variable term. Two different variable terms, but they are numeric factors of variable terms. The 5 and the 10 are constants. Those terms have no variable with them, so those terms are called constants. Okay, in a nutshell, this right here is really important. You need to recognize that you need to deal with the constants first before dealing with the coefficients. So in solving this, you would either solve for the 5, deal with that 5 first, or deal with the 10 first. The last thing you deal with are the coefficients. Okay, so you're going to use the addition principle to move the constants to one side of the equation, and use the variable, the constant. You're going to use the addition principle to move the constants to one side of the equation, and then you'll move your coefficient terms to the other side, in a nutshell, if you have more than one. And then the last thing you'll do is the multiplicative inverse principle. That probably doesn't make any sense, so we're just going to go ahead and start a couple problems. We've got 9x plus 6 is equal to 51. Now 9x, that's your variable term, so 9 is a coefficient. 6 is a constant. That's where we want to start, because that constant is on the same side of the equation as our variable, but we need to deal with that constant first. So you're going to ask yourself, how do I rid this side of the equation of that? This equation of that variable, that term. So I need to go ahead and subtract 6 from each side, because again, our goal is to try to get that variable by itself, and so this 6 is connected to it by addition. We undo that with subtraction. This will eliminate. When I go to collect this side here, I end up with 45. When I bring my variable term down, it just comes down as 9x. Now again, keep in mind I was drawing my computation line there to say that I'm bringing everything down. Now we've got a new equation. 9x is equal to 45. This is multiplication. Okay, so we think about, how do we undo multiplication? With division. And so we draw this little line here to recognize division. If I divide this left side of the equation by 9, I need to divide the right side by 9. When I carry out that division, these eliminate, and I've got x is equal to 9 goes into 45 5 times. So again, I want to make a big deal out of the notation as well as the steps here, but we dealt with the constant first, and then we dealt with the coefficient next. Okay, I drew the computation line to say that I was bringing everything else down, collecting things and bringing them down. I drew a small little line here, small little line here. Those lines are indicating division, very different than a computation line. So I just want to make sure that you understand your own notation. Moving forward, on to our next one. My variable is on the left side. 8 is the coefficient. The negative 4 is the constant. That is added to the variable term here. I need to get rid of that. That's a negative 4. The additive inverse of negative 4 is additive 4. So I'm going to add 4 to each side. That eliminates. I end up with 8x is equal to 32. This is a coefficient. This is implying multiplication. We undo multiplication with division. So I'm going to divide this side by 8. This eliminates. So now I have x is equal to 4. Again, notice the notation. We drew our computation line, brought everything down. We drew little division lines, and that implied division to simplify that. Okay, on to our next one. Our variable here is second again, but it's still on the left side. We've got negative 18 as our constant. We're going to use the additive inverse to eliminate that. So I'm going to add 18 to each side. So I end up with negative m is equal to negative 39. Now again, we can use that little trick that I don't really want negative m, I want to know what m is. And so you can either multiply each side or divide each side by negative 1. I have room here, so I'm going to go ahead and just divide each side by negative 1. That eliminates, so I have m is equal to 39. Okay, going forward. Again, variables on the left side. I've got negative 4. I'm going to add 4 to each side. Draw a computation line. This eliminates. So I have negative 8b is equal to 12. I need to divide each side by the negative 8 to get that b by itself. That eliminates, so now I have b is equal to, and you're like, wait a minute, that doesn't go in there, that doesn't simplify. Well, both numerator and denominator are multiples of 4, so I can divide each numerator and denominator by 4, and I would end up with a negative 3 over 2. Now notice I put the negative above, where here it was below. In this case, it's saying that this whole fraction was negative, even though the negative is in the denominator. In this case, it's saying the whole fraction is negative, even though the negative is in the numerator. It means the same thing. The fraction is negative. But these both reduced. This reduced to negative 3 halves. I just want you to recognize is that, hey, moving forward, things aren't going to always simplify into whole numbers. You're going to end up with some fractions. Okay, and our next one. First question, where in the heck is our variable? It's way over here on the right side. So that's where I need to start, is on that right side. I want to deal with my constant first. The 8 is the constant. I want to get rid of that. It's a positive 8. The additive inverse of that is negative 8. So I'm going to subtract 8 from the right side, so I have to subtract it from the left side as well. That eliminates here. When I'm subtracting a negative from an already negative, that actually means I'm going to total up and figure out how many negatives I've got. I've got negative 99 is equal to 9 over d. Again, I'm trying to get the variable by itself. That's connected by multiplication, so I undo that with division. So I'm going to divide the other side by 9. I end up with d is equal to negative 11. Okay, this one looks a little funky, but don't get freaked out on it. My variable's on the right side. I've got 3 connected to it. That's a positive 3. I undo that with subtracting 3. So if I subtract 3 from the left side, from the right side, I have subtracted from the right side, left side. I'm not even getting my direction straight here. Sorry about that. So that eliminates here. When I collect these two, I end up with negative 2 is equal to negative 1/2 m. Little thought on this. This is connected by multiplication. I could undo this by dividing, but I'm dividing by a fraction. That's kind of funky. We might want to think about our multiplicative reciprocal rule, that I need this 2 to reduce with a 2 up here, and I need the negative 1 to reduce with a negative 1 down here, or basically multiply both sides by negative 2. That all reduces, and I get m by itself. If I'm multiplying this side by negative 2, I need to multiply this side by negative 2. Now keep in mind, I was saying negative 2 here because really I was saying 2 over negative 1 is equal to negative 2, so I multiplied this side by negative 2. Even though it looks like I wrote them differently, they have the same meaning. So I end up having m is equal to 4. Okay, going forward, that was just straightforward two-step equations. Just our variable ended up being in different places, which makes that a little more interesting as we move through these other ones. As we move on, we're going to start dealing with some different combinations, and so I'm going to hold on to that for our next video.